acquainted with mechanical engineering. We are going to go over a few points of why mechanical engineering is important. So let's start with what is mechanical engineering? Mechanical engineering is the application of principles and problem-solving techniques of engineering from design to manufacturing to marketplace for any object. Mechanical engineers analyze their work using the principles of motion, energy, and force, ensuring that the designs function safely, efficiently, and reliably, all at a competitive cost. Mechanical engineers make a difference. That's because mechanical engineering careers center on creating technologies to meet human needs. Virtually every product or service in modern life has probably been touched in some way by a mechanical engineer to help humankind. This involves solving today's problems and creating future solutions in healthcare, energy, transportation, world hunger, space exploration, climate change, and more. Being ingrained in many challenges and innovations across many fields means a mechanical engineering education is versatile. To meet this broad demand, mechanical engineers may design a component, a machine, a system, or a process. This ranges from the macro to the micro, from larger systems like cars and satellites to smaller systems like sensors and switches. Anything that needs to be manufactured, indeed anything with moving parts, needs the expertise of mechanical engineer. What do we study? What are our major subjects? So mechanical engineering study can be divided in three major components: design engineering, thermal engineering, and production engineering. So first, let's start with design engineering. Design engineering deals with creating, design, and building new machines that improve the efficiency of existing ones. Design engineers and problem solvers who bridge the gap between traditional engineers and design. It's a discipline which draws on knowledge of manufacturing techniques, product development, technical design, and rapid prototyping to bring new innovations to market. It also focuses on improving existing products and processes used to making them. Second field of study is thermal engineering. Thermal engineering is a specialized subdiscipline of mechanical engineering that deals with the movement of heat energy and transfer. A thermal engineer will have knowledge of thermodynamics and the process to convert generated energy from thermal sources into chemical, mechanical, or electrical energy. Many process plants use a wide variety of machines that utilize components that use heat transfer in some way. Many plants use heat exchangers in their operations. A thermal engineer must allow the proper amount of energy to be transferred for correct use. You know this, like coal, nuclear, and many more type of power plants are designed by mechanical engineers in form of thermal engineer. Now moving on to the last part of this section, production engineering. Production engineering, also known as manufacturing engineering, deals with planning, designing, developing, and managing of various processes to produce high quality products. It mainly focuses on machine tools, material science, tribology, and quality control. Production engineers will be planning and scheduling the production in any manufacturing industry. They will be programming the CNC machines to produce engineering components, and also they are responsible for quality control, distribution, and inventory control. Specializations. Now moving on to the third section of this session, specializations, your future career options. You may work in these fields in future as a mechanical engineer or maybe even master in these fields. There are too many, but I've listed down a few important ones. Aerodynamics. Obviously, many of you already know this. It is a study of forces and resulting motion of objects through the air. Studying the motion of air around an object allows us to measure the forces of lift, which allows an aircraft to overcome gravity and drag, which is the resistance an aircraft feels as it moves through the air. Biomechanics. Biomechanics is the study of the structure, function, and motion of mechanical aspects of biological systems. Biomedical engineers greatly contribute to the advancement of medical-related technologies. In studying medicine and biology, these engineers develop technologies such as medical diagnostic machines, medical instruments, artificial organs, joint replacement parts, and prosthetic devices, all with the goal of improving the health and quality of life for others. Energy systems. I think we briefly discussed about this before. An energy system is a system primarily designed to supply energy services to end users. Energy engineering or energy systems engineering is a broad field of engineering dealing with energy efficiency, energy services, facility management, plant engineering, environmental compliance, sustainable energy, and renewable energy technologies. Mechanical design. Mechanical design is to design parts, components, products, or systems of mechanical nature. And I think, yeah, we covered this topic as well before. So let's move ahead. Materials and structures, the study of properties of solid materials and how those properties are determined by material composition and structure. This is more of a research focused field. research and production of materials that fulfill the requirements of the project. Vibration acoustics, controlling the vibrations, measuring and monitoring them, and preventing harmful vibrations. Unnecessary vibrations are obviously harmful for any component. It could lead to wearing down of it and essentially reducing its life. And the easiest example for acoustics that I can give you is the exhaust system of a car, and also your headphones design, its comfort levels, and its driver tuning. Sound, obviously, is a very important part of the experience that the end user gets. So these are some of the specializations that you can do, and there are again a ton of them, but these are some that are interesting that I found. So that's it for this technical session.